This week you've been learning about transcription and translation. Similarly to the process of DNA replication, you start off with your double helix of DNA, and here we have a fragment of DNA. The DNA double helix unwinds, and one of the strands of the DNA fragment is going to be used as a template to create a corresponding strand of RNA through the process of transcription. So the 3' to 5' strand of DNA is going to be used as our template strand for transcription. Transcription occurs in the nucleus, and the strand of DNA is used as a template to make a corresponding strand of RNA. Now, if you can recall, RNA nucleotides consist of A, U, C, and G, whereas DNA nucleotides consist of A, T, C, and G. So this is how transcription works. Transcription is initiated, and RNA polymerase is going to read the DNA template, and it's going to add the correct RNA nucleotides. So if you have a G in your DNA strand, the RNA polymerase is going to add a C. If you have an A in your DNA strand, then RNA polymerase is going to add a U. If you have a T, you'll have A. If you have A, you have U. If you have C in DNA, you'll have a G in your RNA strand, and we will continue to elongate as we finish our transcription. U here, C bonds with G, G bonds with C, T bonds with A, C bonds with G, A bonds with U, C bonds with G, and T bonds with A. Now we have the termination of transcription. So we initiated transcription, elongation occurs when RNA polymerase adds the nucleotides to the growing chain, and then termination occurs, and our RNA molecule has been released, where it proceeds into the cytoplasm. So I'm going to go ahead and rewrite my mRNA transcript right here that we just figured out due to our transcription above. And it's always good to double check to make sure that if you are rewriting it, in this case, that you rewrite it correctly. So let's double check that we've written our mRNA transcript correctly. Okay. So now we're going to go ahead and translate this RNA into amino acids. So to do that, to start translation, we have to read what is called a start codon. So we're going to go ahead and look at our mRNA transcript, and here we go. The start codon is AUG. So we're going to start translation. Now we go ahead and divide up the RNA transcript into sets of 3. 3 nucleotides is called a codon. So we had our start codon here, AUG, and now our next codon is CUG. And then the other codon will be CAG, and then our last codon here in the strand will be UGA. So now to translate this into the amino acids, we need to use a codon table. And so let's take a look at our codon table and see what these amino acids are. So we had first AUG, our start codon, and as you can see, we have AUG, which codes for the amino acid methionine, MET for short. If we look at our next codon, CUG, we go ahead and look at our codon table, and we have CUG, which codes for the amino acid leucine, abbreviated LEU. Our next codon is CAG, and if we look at our codon table, you'll find it right here, CAG, that codes for the amino acid glutamine. And then we have our last codon is UGA. What's that? Actually, UGA is one of the 3 possible stop codons. And so translation is initiated by reading a start codon, The elongation occurs as the amino acids are produced based on the codons that exist in the strand, and then termination occurs when you read a stop codon and translation has ended. So that is a demonstration of the process of transcription and translation.